Hi everyone, my name is Kajal Galotra. So in this video, we will be talking about analysis of any algorithm. First of all, why do we need to do the analysis and what exactly is the analysis of any algorithm? You are writing a solution for your data structure problem and you have multiple set of solutions for that given problem statement. Now you want to decide that which solution among all the solutions are best. There is some mathematical part of programming which you do in order to calculate that which algorithm is best for me, which algorithm is giving me the solution in less time. Now let's say you don't want to go into the mathematical part of your programming, okay, and you have one more way to check which solution is best. For example, you can have some test cases, right? Let's say you have 10 test cases which you want to perform onto multiple algorithms which are present for you, and you want to perform the same set of test cases onto every algorithm so that you can come to a conclusion that okay, this algorithm is best for me, right? That is one more option. But now the problem here is, the first problem is that you're wasting a lot of time in order to check that okay, let's say I have 10 solutions, which algorithm is performing best with all the 10 test cases, right? So that means you're wasting your time, you're giving that 10 test cases to all the given algorithms. Second point is, what if your test cases are not that strong, right? Maybe your test cases are not covering every aspect of your algorithm, right? So the point is, even after providing the test cases, you may not able to come onto a solution, right? So what is the best way to analyze the algorithm? There is some mathematical part, okay, which you perform onto your algorithm and you can come to a conclusion. Now let's try to analyze, or let's try to see what exactly is this mathematical part of programming. So this asymptotic analysis came out from a word called asymptote, okay. What exactly this asymptote means? Asymptote means value at infinity. So inputs are tending towards infinity, and that type of analysis is known as asymptotic analysis. As the word asymptote means value at infinity, so we are assuming whatever inputs are expected, we are giving the inputs that are very high in number tending towards infinity, and then whatever analysis we are doing, that analysis is known as asymptotic analysis. In order to see what exactly my algorithm is doing at bigger values, we are requiring one term which is called order of growth. Now let's try to understand it with an example. Let's say you have a function like this. So this function have three terms. So this is the first term, n into n. This is the second term, n into 10, and this is the third term, which is 50. Now for n is equals to 2. So n equals to 2 means n star n is 4, right? 2 star 10 is 20, and this is 50. So if n is equals to 2, this 50 is the biggest element. This 50 is the biggest number. If n is equals to 6, so I am changing my inputs. I am taking my inputs to the higher side. Bigger number I am taking as my inputs. So let's say my n is 6. At that time, n into n will become 36. 6 into 10 will become 60, and this will still remain 50. So 60 is the biggest number. So can I say the second term is the biggest here? N is equals to 100. So if n is equals to 100, this 100 into 100 will be 10,000, and 100 into 10 will be 1000, and it will be 50. So for all these inputs where my input number is getting increased, at that time this term is increasing fastest among all these terms, right? 50 will still remain the same no matter what n I am providing. This is increasing, this term is increasing faster than this one. So this is the term among all these three which is growing fastest. So this term will become the order of growth. So if I am talking about this function, the order of growth is n square. Order of growth, it focuses on the term which is growing fastest when the input size is increasing. So highest growing term is also known as order of growth. So you have to tell me the order of growth for this function, where C1 and C2 are constants. So for this function, C1 into n cube, C2 into n square, what is the order of growth? If comment down if you know what is the order of growth, and I'll give you thumbs up if your answer will be correct. Okay, now I know that I'm doing asymptotic analysis where inputs are tending towards infinity. For that I needed this order of growth. Now let's try to understand what exactly this asymptotic notation means. So whenever you are doing analysis, you need a notation in by which you will represent your analysis, right? So the first one and the most important one is known as big O notation, second is known as theta notation, and third is known as omega notation. All these three notations are using order of growth. So you will have a function, you will have an order of growth, and by using these notations you will be providing your analysis. Let's try to first understand the big O notation. This big O notation is represented by this symbol, which is O symbol. Okay, big O notation, O symbol, and inside this order of growth you are writing the actual order of growth or greater order of growth. What I mean is, for example, if I'll come back to the previous example, here the order of growth was n square. If I want to show asymptotic analysis for this function, I can use O, which is big O notation, and inside the braces I can either write n square, which is actual order of growth, or I can also write n cube because it is greater than n square, right? So that is, inside this O you can either write the greater or equal to the actual order of growth. Okay, that is big O notation. Now let's come to theta notation. This theta notation is represented by theta symbol, and if you actually want to show the theta notation if you actually want to use theta notation for your asymptotic analysis, you have to write the order of growth inside this theta symbol, which should be exactly equal to order of growth. So if you want to show order of growth in terms of theta, so you have to use theta and then n square. You cannot write n cube, you cannot write theta n, but you always have to write the exact order of growth, which is n square for this function. Okay, now third one is omega notation. Omega notation is represented by omega symbol. This is the symbol by which omega notation is represented by. Now inside this, so whenever you want to use omega notation, you can use the actual order of growth or less order of growth. If I want to use, for this function, if I want to use omega notation, so either I can use omega of n because n is less than n square, or I can also write omega of n square. I can write equal, which is n square, or less than, which is n, but I cannot write omega of n cube because n cube is greater than n square. Okay, so if I am talking about omega notation, you can either write less than or actual order of growth. Okay, so that was the theory part of it. Now let's try to understand that what is the importance of picking the best solution. You are choosing the best algorithm, your performance will be higher, user will be getting the responses in the less time, and that is the first point. Cost saving. So let's say you are not using the appropriate algorithm, you are using some resources are getting used in order to calculate the response. At that time you are expending some money onto that, right? So if you have used your best algorithm, your money will be saved. Then scalability. So if your solution is best, so that means your solution can give solution in less time, so that multiple users or multiple tasks can be done in efficient manner, right? So if your algorithm is best, your algorithm will easily scalable. Then the last one is user satisfaction. So if your algorithm is giving responses in less time, so the user satisfaction will be the most, right? So that is the importance of picking up the best algorithm. Now let's try to see that what exactly are the annotations. So for example, this is my function n, which is c1 n square, c2 n, and c3, right? Now I want to say that for this function, my complexity is order of n cube. Now I know that I am using omega notation, and inside my omega notation either I can write exact order of growth, which is n square, or I can also write greater order of growth, which can be n cube. So this will be correct, right? Now I want to write n log n, but actual is n square. N log n is smaller than n square, so I cannot write this, so it is incorrect. Again n square root of n, which is again smaller than n square, so this is also incorrect. If I want to say omega, now you have to tell me, if I am using omega, either I can write less or equals to the order of growth. Omega of 1 is less than actual order, so it is correct. If I am using omega n square, because it's the actual order of growth is n square, I can use with omega, so it is also correct. But if I am writing omega n cube, it is incorrect because n cube is greater than n square. Then I am talking about theta. So inside my theta, either I could write n square, which is correct. I could not write order theta of 1, which will be incorrect. I cannot write anything except n square inside theta. Everything will be incorrect because theta is expecting the actual order of growth inside it. If I am saying n into log n for big O notation, because it is greater than n square, which is also correct because n square log n is greater than n square, right? So now if we have 3 notations, then why people are like mostly focusing upon big O notation? So okay, first of all, let's take it as an example. I am a seller. I am saying you that buy my algorithm, and this algorithm can at max take 10 milliseconds. Okay, I am telling you that no matter what, at max or at worst, it can take 10 milliseconds. And one more person is there who is saying that in the best cases, my algorithm can take 2 milliseconds. Now you think that which algorithm will you be buying? You know that at best case it is performing at 2 milliseconds, but you don't know what is the worst case of that algorithm, right? So everyone want to buy the algorithms for which the worst case is mentioned. Okay, so that's why, because big O notation has something bigger or maybe equal to the order of growth, so that means it can be the highest number. I'm not saying big O 1, right, where the order of growth is n square. That is not correct. So in in big O notation, either I can write the actual order of growth or I can write the maximum order of growth. So the point is, I'm giving you the upper limit with the help of big O notations, right? So that's why big O notation is very important. It gives you the worst case of your algorithm. It gives you the upper limit of your algorithm. Okay, but I'm saying log of log n, or I'm saying log n, or I'm saying n square, n into n log n. So you don't know which term is bigger. So you can keep this in mind, that if it's a constant, it is taking least time. If it is log of n, it is taking greater than log constant time, but again it is smaller. If I'm talking about log n, it is greater than log n, but less than square root of n. Okay, so that's how you can keep this sequence inside your mind, and it will help you understand it in better way. Okay, so there are some terms that we use. If I'm having order of 1, I can say it is taking only the constant time. If it is order of log n, I can say it is taking logarithmic time. If I'm saying order of n, I can also say it is taking linear time. If I'm talking about order of n log n, I can say log linear time. Okay, if I'm talking about order of n square, n cube, I can also say polynomial time it is taking. If it is 2n, 3n, 4n, something like that, I can say it is taking exponential time. If it is n factorial, I can say order of n factorial time. Okay, these terms we can use at the places. Now, people maybe are not sure about logarithmic, but what I can tell you is logarithmic is inverse function of exponential. 2 into 3 will be 6, right? And I can say 6 divided by 2 will be 3. So these two, multiplication and division, are just opposite to each other, right? Similarly, opposite to the power is logarithmic. So if I am saying 2 to the power 3 is equals to 8, right? So if I'll take a log, so log is opposite to it. So log of 8 will be equal to 3 log 2. Okay, so log is opposite to the power. So what is the meaning of 3 log 2? So I am saying whatever is the number here, 2, right? If I am powering it, I will be getting the value. So opposite to the power is log. Okay, so we'll understand it in some more time when we see it in detail, but the idea is, let's say you have 1000, right? So let's say you have 1000, I can say it's 10 to the power 3, right? So if I want to take it as a log, I can also say log of 1000 will be equals to 3 log 10. Okay, so the point is, if I power this the number which is coming forward or coming the first, if I'll power this number, I'll be getting the same number. So log is nothing but opposite of the power. Okay, so that is about log, little bit about log. But now are you getting it? Like from 1000, if you are taking the log, you are getting 3. So 3 log 10. So that means it is reducing a big number with a very small number. Okay, so you took 8 and you got 3 log 2. I'm talking about 1000, it is just giving you 3 log 10, right? You have to tell me what is the order of growth for this. So this is my function where it is n square log n square square root of n into log n, and n square plus 10 into n into log n. Okay, so this is your function. You have to tell me which is the term which is growing fastest with n. Okay, so it is n square, it is also n square. Now you have to tell me log n or square root n, which is bigger. Square root n is bigger, right? If you are confused with this, you can also see it here. Square root of n is greater than log n, right? Okay, so now you know this is bigger. Now this is not even, you are not even taking it into consideration after that. Now let's talk about this one. So this n square and this is only n, so that means this term is bigger. This is n square, this is also n square, but it has square root with this, but this does not have any square root. It has 10 into n log n because it's not n square, so that means the biggest number among all the terms is this one. Okay, so the solution and the order of growth for this function is n square square root of n. So whenever it comes to time complexity, meaning how much time your algorithm is taking to get executed, okay, so that is known as time complexity. So big O notation will be telling the maximum time taken by algorithm in the worst case. I know whatever term is written inside my order, my O, okay, will be the biggest one. Constant operation. Okay, for example, let's say you have a computer, okay, and you want to do something onto your computer, right? Everything which you are doing onto your computer is has been broken down into instructions, right? So your computer says, if it is taking my maybe 100 cycles, 100 is just a number, okay, it's not the fixed number, but what computer is saying, computer says if any calculation or any instruction is taking only my 100 cycles, I can say it is taking my constant time. Okay, so all the operations like plus, minus, division, multiplication, less than, equals to, checking, greater than, equals to, less than, greater than, equal, not equal, every operation can be done in few cycles, which machine says it's taking constant time. So if I'm talking about time complexity, and you can see your plus, minus, division, multiplication, greater, less than, anything, okay, so you can say the time complexity for this is constant. Okay, it's taking very less number of cycles of your computer, so you can say it is done inside my constant time. So these all are operations which are done inside your constant time only. Okay. So that was about the basic idea of your complexities. In the next part, what we are going to do, we will see some examples where we'll be talking about how to calculate the complexities. Now we know, like, if I want to conclude this class, I can say you, first of all, there are multiple notations to show you the asymptotic analysis, and there are which is omega notation, theta notation, and big O notation, right? Then there is something called order of growth, which actually you need to calculate so that you can understand, or you can tell that this term will come under any kind of notations, right? And what is asymptotic analysis? And asymptotic analysis means the analysis that we are doing at input, tends to infinity. So that was about this part. In the next part, we will be talking about some examples in which we will try to calculate the big O notations. Okay, thank you so much for watching.